Okay, so good evening, everyone. I was just giving some time so people can log in. Welcome to the third edition of RancHER or RancHER 2023. I'm glad that we are all connected tonight. I'm really excited about this edition. I think this program gets better and better every year. I'm really excited to be able to bring some amazing people, some amazing women to be able to show the work they're doing there. So if you don't know me, I'm Juliana. I'm the host of RancHER. I'm assistant professor and beef extension specialist at Oregon State University. I'm based in Burns in Eastern Oregon, and I am based at the Eastern Oregon Agricultural Research Center. At OSU, my job is divided in research and extension. So as part of my extension component, I always, every year, bring the RancHER program to you guys. So since this is our first evening together, I just want to give you guys some housekeeping information. We have two speakers tonight, myself and Dr. Robin White. Robin will be our first speaker, and then we'll follow with my presentation. We'll do questions at the end of each talk. If you have any questions, you can ask those questions at any time using the Q&A box. It should be at the bottom of your screen. So you can type those questions there, and we'll be answering those questions at the end of each talk. As we do every year, we're going to have a prize drawing. We'll do right in the middle of the night tonight. Dr. White cannot join us for the second half, unfortunately. So if you have questions, make sure to ask those questions as soon as she's done. And then we also going to do the door prize right in the middle of talks. So I guess that's all the housekeeping information I have for tonight. It is with a greater pleasure that I introduce Dr. Robin White. Dr. White earned a bachelor's degree and a PhD degree from the Department of Animal Science at Washington State University. She then completed a postdoctoral fellowship with the National Animal Nutrition Program and AFRI-LI postdoctoral fellow. White is currently an associate professor of animal systems management and associate director of the Center for Advanced Innovation in Agriculture at the Virginia Tech. Her team focuses on improving understanding of ruminant nutrition and leverage nutrition and technologies and strategies to enhance sustainability by exploring basic mechanisms governing rumen fermentation, applying models and technologies to enhance feed efficiency, and characterizing strategies to enhance food system sustainability. Robin, thank you very much for joining us tonight. I think your talk is going to be very eye-opening to a lot of people. I'm really excited to hear what you have to share. And thank you again for accepting the invitation. The screen now it's yours.
Excellent. Thank you so much for the introduction, Dr. Ranchez. It's my absolute pleasure to share some of our work with this audience. The title of what I was asked to speak on is this concept of livestock and the environment. So talking a little bit about navigating the evolving landscape of greenhouse gas emissions, sustainability, and food systems. If you have any questions that you're unable to answer or to ask, or that we're unable to get to in the Q&A today, I'll highlight that my email is here on the first slide, and I'm always happy to chat with individuals that have specific queries in this space. Our roadmap for today is going to focus on some definitions and history around food sustainability and the international conversations driving the food sustainability narrative. We'll talk a little bit about a current snapshot of what food systems look like in the global setting today. And then we'll transition more to a local setting and ask this question of how at the farm level do we begin to navigate this sustainability pledge that industries are making. And we'll talk about some of the potholes or the future perspectives that are in this space that we want to be paying attention to as we begin to work on individual operations toward enhancing sustainability and contributing to our broader food systems. So to begin, jumping right into this concept of food sustainability, I want to answer this question, right? Because it's one of the most common things that we got asked maybe about a decade ago is, what is this sustainability word? It means so many different things to different people. And so, I really like this definition. It came out of the 2021 World Food Summit. And it's a sustainable food system is one that contributes to food security and nutrition for all in such a way that the economic, social, cultural, and environmental bases to generate food security and nutrition for future generations are safeguarded. And there's a number of reasons why I really like this definition. First and foremost, it focuses on the concepts of food security and quality nutrition. We're all at this point very familiar with our projected population growth curve. This graph here is showing from the 1700s out to a projected 2100, and we can see the estimation that we're likely to reach a population of 10 billion people. But many people may not be familiar with the statistics here on the right-hand side of the slide that show, according to the FAO statistics database, food insecurity on the global scale is increasing. It's increased from roughly 8% just back in 2014, 2015, up to close to 10%, 2019, and through 2020 and 2021, as those new data become available, we're seeing that trend continue. So already, as we have this expansion of our growing population, we're also experiencing increasing challenges associated with food security. So these concepts of food security and quality nutrition are central to the objectives of sustainable food production. This definition also highlights what we traditionally thought of as maybe the 3 tiers of sustainability, or the pegs of the milking stool that is sustainability. And those would be economic, social, cultural, and environmental. We know that here on the far left, showing global average food price inflation, the economics around agriculture and food are a constant challenge, and one that will continue as we face growing demand and the challenges associated with climate change. From an environmental standpoint, these data are showing surface temperature changes on the Earth's surface from 1960 up to 2020. And we can see, again, substantial volatility in those data and a general increasing trend that we have to cope with in our agricultural settings. And we have to be aware of our contributions too. And then finally, from the social or the cultural lens, we can see that the global proportion of the population involved in agricultural employment over the last 70 years or so, with 70 being 2020, 0 being today, minus 70 years, that population has decreased to about 1%. So we have a fraction of the food consumers in the world that are involved with the process of producing that food. And there's a number of challenges that come along with the increasing distance between our food producing and food consuming populations. Finally, this definition is very nice because it highlights the fact that there's a time scale associated with sustainability. We're operating today in a way that is attempting to safeguard the chances of feeding future generations. And what I'd like to highlight in these different graphs, each one of them shows slightly different outcomes, but each one has a commonality in that they're looking at the potential variation around the future. There's tremendous uncertainty about what things like global population may look like in 2100. There's tremendous uncertainty around what projected land use will look like in 2050 or 2100. And there's considerable uncertainty around how global hunger may change by, again, 2050 in this case. So we have to operate with this uncertainty in mind, and that's part of this concept of feeding our future generations. And what this means is that as an industry, it's our responsibility to work toward sustainable solutions that keep these themes in mind. We have to think about economic, social, cultural, and environmental elements of our production systems. And we have to think about the time scale whereby our actions influence the products produced today and our opportunity to produce products in the future. Now, in the global research arena around food sustainability, there's been a history of looking at this as a problem. And what do humans do with problems, right? We prioritize the potential challenges. We identify the elements within our system that contribute to those challenges, and we focus on those elements and attempt to limit their contributions. And that's really the process that has occurred through time as we begin back in 2009 with a seminal paper by Rockstrom and colleagues that highlighted the challenges associated with a safe operating space for humanity, and highlighted the fact that our existing activities exceed that safe operating space and move into this area of high risk tipping points where human activity influences the environment in a potentially irreversible and negative direction. We exceed those thresholds when looking at biogeochemical flows of nitrogen and phosphorus, and when looking at biosphere integrity. And we're in this zone of uncertainty or increasing risk when we look at the trajectory of land use change and climate change. So these would be our primary problems that we need to be addressing in the environmental realm of sustainability. Now, what's happened in the research space after this boundaries publication is that there's been a number of high-profile studies prioritizing the various contributions to these potential environmental areas of interest. A great example is the Eat Lancet report, of which this Springman paper from 2018 is a contributor. And in this paper, this is looking at various agricultural commodities and their contributions to things like greenhouse gas emissions, crop and land and water use, nitrogen, phosphorus application. So you see the alignment between these environmental targets and those areas for which we are at that zone of uncertainty or at high risk of exceeding our safe operating space for humanity. And what we see, particularly for greenhouse gas emissions, is that the red portion of these bars, animal products, contributes a substantial portion in this analysis. The two timeframes here are looking at 2010 as a snapshot or 2050 as a future projection, assuming economic business as usual. And these types of studies have been the major step in moving from prioritizing our problems to identifying the current contributors. The logical follow-on to that is the quite frequent recommendation to reduce consumption of animal products for environmental objectives, which of course is this third element of our problem-solving approach, limiting the contributions of those sectors, i.e. of animal product production, which currently contribute to our problem, i.e. greenhouse gas emissions or climate change. But in looking at these types of numbers, it's really important to remember that global context matters. Oftentimes, these types of assessments are done using international data on a global scale, as opposed to looking at individual countries' data. And if we use the United States as an example and look at some of the sources of greenhouse gas emissions, livestock in the United States account for 41.8% of our agricultural greenhouse gas emissions. That's almost 20% lower than the global number, where livestock account for 58% of agricultural greenhouse gas emissions. Now, if we skip to the bottom line of this table, in the US, agriculture accounts for 9.3% of our total emissions footprint. Globally, however, agriculture accounts for 25% of the total emissions footprint. The net result when we look at livestock as a percent of our total emissions footprint is that in the US, livestock accounts for less than 4% of total emissions, whereas the global number would put livestock emissions contributions closer to 15%. So you can see how you may make very different conclusions about the importance of individual sectors when you're looking at the global scale compared to individual countries' scales. It's also important to point out that in these types of problem-solving exercises, it's really important to consider practicality. In some work that we did back in 2017, we highlighted the fact that if we omitted animal agriculture from the US agricultural system, we would achieve about a 28% reduction in agricultural greenhouse gas emissions, even though in this assessment, animals contributed in our baseline representation of today's agricultural system, roughly 50% of emissions. So there's counterbalances and shifts that occur in agricultural systems when we undergo dramatic changes like the omission of an entire industry. It's important to point out in this assessment, we made some assumptions about perhaps needing to synthesize fertilizer to replace the nutrients which are currently coming from livestock manures, and to combust inedible byproducts, which livestock currently recycle. And you'll note that those two bars, they're the red and the gray bars at the very bottom of the right-hand set of bars that is labeled minus animals. They account for very little of the counterbalancing effect here. Largely, it's the expansion of agricultural land for the production of food for humans that causes only a 28% reduction in agricultural emissions, not the 50% currently associated with animals. When we do this out to an estimate of the percent change in total US emissions, we're looking at a less than 3% change. Associated with that less than 3% change in total US emissions, we would see an increase in the availability of food produced from the US agricultural system, 320 billion kilograms versus 260. However, the profile of that food would shift tremendously to increase the production of cereal grains and legumes in particular. As a result, although we'd have greater availability of energy in a number of macro and micronutrients, we would have more nutritional deficiencies, particularly in these nutrients highlighted: calcium, vitamin A, vitamin D, riboflavin, vitamin B12, DHA, EPA, arachidonic acid, and alpha-linoleic acid. The counterbalancing of a 3% reduction in our total emissions with an increase in the number of nutrients produced in insufficient supply to meet the US population's requirements is a trade-off that we need to be considering when we're talking about sustainability, because sustainability goes beyond the environment. It also has to consider things like food security and nutrition. We also have to point out that the time scale for these types of statistics needs to be considered when making recommendations. There is rapid change in our environmental impacts in agricultural systems, particularly as we look at things like the developing world. So this is data from an FAO publication that focused on 1997 to 2012, and it highlighted that 26% of land is used for grazing, and each year 13 billion hectares of forest are lost due to land conversion for agricultural uses such as pastures or cropland. However, if we look at an overlapping time frame from 2005 to 2018 from the exact same source, this is FAO stat data, what we can see is that there is a decrease in tree covered areas. It's about 120,000 hectares per year, not 13 billion. And there's actually a substantially greater decrease in the hectares of grassland over this time frame. So what we'll see from these data is that although there is still a reduction in tree covered areas, it's not necessarily going to production of pasture land. There is counterbalancing and increasing shrub covered areas increasing herbaceous crops, urban areas, and aquatic or flooded areas. Paying attention to the time frames for these types of data can help us make sure we're keeping our recommendations contemporary to the issues faced in today's agricultural systems. This element of timescale also has some important practical components. So we mentioned the Eat Lancet report earlier. If you're not familiar with it, this is the recommended diet proposed in the Eat Lancet report. We're looking at different types of foods and the recommended allowance in terms of grams per day for these food categories. And if we scale that diet up to feed a population of 10 billion people and compare it to what's produced in our agricultural systems today, we would see that we would need to consume the entirety of our vegetable supplies, the majority of our fruit supplies. We need a little bit of an increase in dairy production, and we need a substantial increase, over double, in production of legumes, and about 5 times the production of nuts to be able to sustain this type of population globally. It's worth asking whether our food production system can increase legume and nut production within the time frame needed to be able to achieve reductions in greenhouse gas emissions. Tree nut production in particular can take quite some time to establish. And so there's some latencies in the system that we also have to think through. So although there's a lot of logic in this problem solving, prioritizing the goals or the targets, identifying the current contributions, exploring how we might limit those contributions, we've been quite narrow in scope in thinking about this last component. How do we limit the contributions of our current contributors? There's no secret that greenhouse gas emissions in particular from animal agriculture is a major challenge, both at the national and the international level. But the fact that it's a major challenge just means that it's an area of opportunity for our industry. Because, of course, sustainable solutions are our responsibility. And because they're our responsibility, we have an opportunity to explore how we can move toward other elements of sustainable food systems, including things like social acceptability and improved economic viability. So in terms of our food sustainability section here, it's important to remember that sustainability is a very complex and it's a multifaceted concept and very much a moving target, but one that we need to start addressing. It's very easy to reduce the sustainability discussion down to exclusively focus on greenhouse gas emissions. But as an animal agriculture community, we need to remember the benefits that we provide to food sustainability while openly acknowledging the challenges and the opportunities that we have to improve our sustainability. As we move into the second section, we'll look at a snapshot of what food systems look like at the global scale right now. And this work, we sought to summarize the current agricultural supplies of human edible nutrients, their sources, and how they correlated with agriculture greenhouse gas emissions and water withdrawal in the context of the population. And we looked at this at the global scale, the scale of individual continents, and we looked into individual countries. This is in part because of that challenge in generalizing data from the global scale down to local or individual country recommendations. So the data used in this assessment comes from the FAO. We look at 10 years of data for 240 different areas. We have 168 crop products, 44 animal products, and we explore things like food loss and waste, agricultural trade, and the environmental impacts of these products. We match this database up with USDA to look at the nutrient composition for 206 different food products, and with requirement data that are sourced both from the USDA and the WHO. We then also bring in an additional paper to estimate the amount of human consumable food that animals consume in each of these areas on an annual basis. In terms of the production data, what we see is that within countries, nutrient production from agriculture, if we standardize it to the population requirement, so what that population needs to consume, our production in general dramatically exceeds what humans require. So in this graph, the excesses in billions of human nutrient requirement years oversupplied by agricultural systems, summed up across all of the countries for which we had data, are shown in the blue in the middle panel. And you can see in many cases, we're exceeding an excess of 10 billion people's requirements, oversupplied by an agricultural system. If we compare that to the deficiencies, those are expressed in red in the left panel, we can see that for some nutrients, for example, calcium, choline, we exceed 3 billion people that are in agricultural systems with deficient supplies of those nutrients. For those micronutrients in particular, where we have the largest quantity of deficiencies, we can see when we put those deficiencies and excesses together in the panel on the far right, that they are actually fairly close to the excesses produced in other countries. So we produce at the global scale roughly what we need, but that production is not geographically balanced such that it is aligned with the populations that need those food supplies. Now, that would be the case for calcium, choline, and some other nutrients like potassium, vitamin A, B12, vitamin D, vitamin E, vitamin K, and some of our essential fatty acids. For many of our macronutrients, particularly when we look at energy and protein, the excess produced on the global scale dramatically dwarfs the deficiencies. And so these types of misbalances in global production present a potential opportunity to explore things like food redistribution and food trade as a tool to ensure that food is getting to the place where it is most needed. Aligned with that type of assessment of our current food sufficiency, it's important to point out that through this assessment, we can do things like looking at the sources of different, in this case, vitamins and minerals by food system. Here we aggregate on the continent level. And what we can see is that for an individual nutrient, perhaps vitamin K at its top row, the patterning of colors shifts dramatically as we move through different food systems. And what that points out is that different cultures are going to leverage different types of foods to meet their needs. The other important takeaway from this kind of nauseating color mash of a graph here is that the sources of various nutrients within continent differ tremendously. There's no single food category that's an important contributor to all of our vitamins and minerals. And that's how we come to this title here, that food systems are necessarily complex. We consume diverse diets because we have diverse nutrient requirements as humans, just as our livestock do. Now, this is kind of a fun graph. What we're looking at here is the scaled nutrient to calorie ratio for a variety of different nutrients. And the box plots are showing the foods consumed by humans. And so what we're looking at is the nutrient density of the profile of foods that we eat. Again, this is done on an individual country basis and averaged out. Here, what we see is that for most of our nutrients, we have the majority of the box plot at a value greater than 1. We have 1 highlighted here in the black vertical line. The value greater than 1 would mean that we are consuming a nutrient-dense source of that particular nutrient. However, we have some nutrients for which we have most of the box plot well under the value of 1. So linoleic acid, vitamin E, choline, calcium in particular, most of our sources of these nutrients are not very dense. What that means is we have to consume a lot of energy to be able to meet our requirement for these nutrients. The interesting thing that I really enjoy about this assessment is that if we look at those sources which are nutrient dense for each of these 4 ingredients, we can see that many of our food categories are a nutrient-dense source of at least one of these nutrients. And interestingly, there is no single food category that is a nutrient-dense source of all of these low-density nutrients. So again, this points out the fact that the diversity of foods included in human diets is in part to ensure that we're able to meet our nutrient requirements without exceeding our energy requirements. Right. One of the other things that we're able to do with this type of analysis is to explore what agricultural products are used for. And this becomes really important when we start to transition to talk about animal source foods in particular. So we can use agricultural products for import and export. We can waste and lose agricultural products, and we can use them to feed livestock. So in this assessment, we look at 4 different representations of the food system: the raw food supply without accounting for animals, the supply adjusted for import and export, the supply adjusted for waste and loss, and the supply adjusted for the net consumption of human edible nutrients by animals and the production of human edible nutrients in animal source foods. What I want to highlight is those last 2 scenarios. So in this case, we're looking at the blue bars and the red bars on these graphs, because this is looking at the net impact of livestock. Our x-axis here is showing the billions of human nutrient requirement years provided by our agricultural system with livestock, the red bar, versus without livestock, the blue bar. And we can see some interesting trends. In places like Europe, North America, Oceania, and South America, there's an increase in availability of most of our nutrients. Here we're looking at things like protein in particular, when we produce livestock products. But that same trend doesn't hold when we look in Asia and Africa. So it's important to remember that although livestock are a net benefit in terms of nutrient availability in places like North America, that's not the case in all production systems. We also want to pay attention to some of the challenges associated with ruminants globally. So here we're looking at that same trade-off in in availability of nutrients when we're accounting for meat only, which would be those blue bars, or meat and milk, which would be the red bars. And the point of this is to say that our meat and our milk industries are very tightly linked, because our meat industries often are serving as an endpoint for male calves and cull cows coming out of our milk industries. And so the dependencies between those industries need to be considered, both when we're talking about the trade-offs in human edible nutrient supply, but also when exploring the environmental impact of these production systems. Finally, we want to show, this is what's called a Bayesian learning network. And so these individual words represent nodes within the system, and the various lines represent relationships or edges between those nodes. This was fit off of our individual countries' data, and so it represents the types of relationships inherent in global agricultural systems. You'll see that we're highlighting various nutrients, and we're expressing nutrients relative to a population's requirement for those nutrients. And we're expressing various types of food products. And again, those are, in this analysis, explored per capita. What I would highlight is that ruminant meat here is going to be one of the only food types which is associated with greenhouse gas emissions. This is in part because of the way that these calculations are done, but it's also in the data going to be one of the strongest driving relationships to indicate the agricultural greenhouse gas emissions from global food production systems. But if we did something like try to minimize ruminant meat production, we would decrease milk production. And through those two activities, we would negatively impact the availability of all of these nutrients highlighted in the pink or salmon color here, one step away in terms of relationships. And if we moved 2 steps away, we would also negatively impact the availability of all of the nutrients in kind of the tan color. Only those nodes which are listed in black would be unaffected by this type of shift. So there are trade-offs that exist in agricultural systems between the provision of nutrients for our human edible food supplies and things like production of greenhouse gas emissions. I will note in this analysis that if you do this same exercise with water, you'd be highlighting fruits and vegetables as the major contributor. And we would be focusing on a totally different set of nutrients, but the same type of responses. So if we target greenhouse gas emissions, we end up with focusing on animal source foods. If we target something like water use, we're going to focus on fruits and vegetables. And in both cases, we experience a decrease in nutrient availability when we try to change the agricultural system to achieve an environmental objective. So in this food system discussion, again, food systems are necessarily complex. They are complex to be able to meet the diverse needs of humans. And there are trade-offs that exist between human nutrition and the environment. And we have to be realistic about those types of trade-offs so that we can identify appropriate ways to move toward navigating sustainability. Now, as we move into this last section, it's important to highlight that in the 2021 World Food Summit talks, we highlighted 2 different strategies for studying food systems: positive and normative approaches. Normative approaches ask this question of, like, what would an ideal system look like if we started from scratch? Positive assessments ask, where within the current food system do we have opportunities to make positive change? Okay. These are not discrepant ways of asking the same question, but they're often posed that way. Really, what we should be doing with these types of positive and normative assessments is trying to learn from both of them to understand the gaps and opportunities and to define within a discipline or an industry the types of actions and strategies that we can use to address those gaps or opportunities. So here we're talking about things like this assessment I just shared with you as a positive approach. That's looking at what does our food system look like today and what are the relationships that we need to be aware of. But normative approaches, such as the Eat Lancet diet, which we've also highlighted a few times in the talk, are really important complements to that type of approach to help us understand what a system from scratch might look like. How can we take these 2 very different frameworks for research and learn from them to work toward a strategy for our industry? And largely, that's what our industry has already done if you look at the commitments to climate neutrality that have been posed. So what we'll do for the rest of the talk is look at a roadmap for sustainability. So here, I propose that really what we're doing within an industry is defining our targets, specifying the rules that we use to explore our progress toward those targets, benchmark today, define the ways that we might be able to improve, implement those strategies, and work toward various metrics of verification. Of course, this is not a terminal process, right? It becomes a little bit cyclic. And so we need to keep that in mind as we are thinking about what the future looks like. Thankfully for us, across the agricultural industries, the goals are largely already set. Our industries have made pledges, and we are now in the process of trying to figure out how we're going to make good on those. If we look at what the rules are going to look like, this is also a little bit in flux right now. And particularly, it's in flux around whether or not we're working on a traditional global warming system basis, or whether we're exploring this concept of warming neutral rather than carbon neutral. The difference is largely in the way that methane is treated by these systems. In a system where we're exploring warming neutrality, constant methane emissions can achieve warming neutral, and decreases in methane emissions can achieve counterbalancing influence on emissions of other greenhouse gases. So understanding that we're operating around this concept of warming neutral, it's useful to look at some of the benchmarking exercises that are coming out. So this work by Liu and colleagues from 2021 benchmarked the US cattle industries under this new GWP star system, and purported that the cattle industries have not contributed additional or new warming since roughly 1986. Here, where we're looking specifically in California, a 1% reduction in methane emissions would support neutrality of these industries within a decade. 1% per year reductions in methane emissions would support neutrality within the decade. So this type of benchmarking becomes really important to understand where we're at today and what opportunities or what targets we need to focus on to move toward warming neutrality to support the pledges made by our industries. So what types of desired behaviors can we use to try and work toward warming neutrality? This is some work that we did back in 2015, comparing nutritional, genetic, and reproductive strategies. So here we have a variety of genetic focused strategies, selecting animals using EPDs, combining with things like a tighter calving window to produce more uniform calves, using on-farm bulls versus using AI bulls, and remarkably enhanced reproductive efficiency, where we try to turn cattle into sheep, twinning. We can look at things like reducing the calving window individually, optimizing nutrition only, or our existing kind of business as usual scenario. And these three plots are looking at the carbon footprint, the water footprint, or the land footprint from these different systems. And what we can see is that carbon footprints in particular are going to be highly sensitive to things like genetically superior animals and enhanced reproductive efficiency. In this assessment, optimizing nutrition wasn't particularly influential, but that's largely because of the approach that we use to ask the question around nutrition. If we look at a different study, which focused specifically on enhancing feed efficiency, which is perhaps one of our most important targets in the nutrition space, we can see with a cost increase of 1 to 20% over a baseline, with animals achieving a current average feed efficiency, that we could achieve roughly an 18% reduction in land use, water use, and greenhouse gas emissions at a 20% cost increase. However, if we're able to push animals toward an improved feed efficiency, we can achieve roughly that same 18% reduction in land use, water use, greenhouse gas emissions with only a 5% increase in cost. So enhancing feed efficiency is an important nutritional target, just like optimizing genetic merit of our animals and optimizing reproductive efficiency become important genetic and reproductive targets. It's also critical to note that there's going to be important regional and climate associated differences in the types of strategies that we use to move toward enhanced efficiency of our production systems and reduce greenhouse gas emissions, land use, and water use. These data are showing differences in the Pacific Northwest versus Midwest systems versus Texas under average climate conditions or those predicted with climate change. We can see that in some systems, there's perhaps minimal influence of climate change, whereas in other systems, climate change is going to have a fairly substantial impact on our opportunity to minimize environmental impacts, land, water, greenhouse gases. It's also important, though, as we think about these types of assessment, that we not lose sight of the rules. One of the differences in this global warming potential GWP star system is that we're looking at changes in emissions over time, and we're looking at absolute emissions. Each of these analyses I just shared with you are focusing on emissions footprints. If we look at the US beef industry emissions intensity, here reported in kilos of CO2 equivalents per kilogram on the left plot, versus our total emissions in kilotons of CO2 equivalents on the right plot, we can see, oops, we're going too fast here. We can see that our emissions intensity has diminished over time, and it's done so quite steadily. However, our total emissions have not changed quite the same way over the period from 1960 to 2020. We had a spike through the 1970s into the 1980s, and then a subsequent kind of decline. And we've largely remained stagnant here through the 2000s. So finding strategies to achieve another fairly rapid decline in total emissions is going to be critical under our GWP star system moving toward warming neutrality. All right, so that gets us to defining targets, specifying these rules, benchmarking what we look like today, defining some of the strategies we can use to make progress. How do we implement these? If it were that simple, if all we had to do was enhance efficiency, largely we'd already be doing it, and we would see very little need for additional change today. One of the challenges around this is that we are getting to a place where we need to focus on reducing total emissions and reducing emissions intensity at the same time. And that may require different types of production practices, such as the direct mitigation of methane emissions in particular. And in exploring how we implement those types of practices, it's important to point out that we have a number of partnerships and programs which are being developed throughout the US to try and inform policy on how to incentivize adoption of climate smart agricultural practices. So I'm using this RIGHT partnership that we've got at Virginia Tech as an example. This is a pilot project where we're paying $100 per animal unit for adopting climate smart practices. So these types of programs are one strategy that we can use to try and offset the costs associated with newer or more advanced strategies to mitigate greenhouse gas emissions. And this might include things like precision grazing, direct methane mitigation, different manure management, et cetera. These programs right now are largely piloted on a regional scale. And so I'm not going to go into, in depth into this particular program, but it's just an example of the types of opportunities that are rapidly emerging in this space. When we think about this concept of efficiency and scalability, these types of programs increasingly are rewarding circularity, upcycling, or the conversion of human inedible nutrients for human edible food production, and reducing competition between humans and animals for food. But they also focus on things like mass balance and ecosystem health. We have to consider concurrent challenges with soil and water quality goals, and oftentimes have an element of biodiversity conservation. So although there's going to be a focus on greenhouse gases, there's going to be a critical need to think more broadly in terms of environmental sustainability objectives to be relevant in these types of offsetting programs. So as we see more and more of these opportunities, we can start to begin thinking about how we can incentivize sustainability-focused practices. And oftentimes that might require rethinking or refining some of our linkages and our understanding between efficiency and sustainability. Very quickly, I want to finish up with some of the concepts that we want to be paying attention to in the future. So in particular, I want to focus on this last element, verification. So these types of programs, like the RiGHT partnership that I just mentioned, are really in their infancy. And one of the major questions that we have unanswered is how we verify the implementation of practices and how we verify the successive outcomes. There are a number of environmental incentive markets that have expanded rapidly over the last decade in particular. And within the scientific literature, there's increasing skepticism or concern around these types of markets. Oftentimes, their verification is not compatible with a life cycle assessment. They don't include all life cycle phases in their accounting or counterbalancing. And oftentimes, they don't account for any sort of negative environmental or social collateral impacts of the offsets that they're selling. So as these environmental incentive markets begin to mature and we see more and more refinement around how verification is done, that may change the feasibility of employing this approach within our agricultural systems. In general, verification strategies can come from prediction, right? This is reliant on a model and its ability to explain very diverse systems. And that's a struggle because models often are inadequate in representing the types of diversity in agricultural systems, even inherent in a country like the United States, without a fair amount of tuning and parameterization to ensure that they're adequate for the individual system. Another option, though, is policy for measurement, which has largely been avoided because it's expensive and it's extremely labor intensive. Sometimes we have the additional challenge that sampling and measurement methods are not always straightforward. They're not always well established. So when we lack a straightforward, reliable, well-established measurement method, oftentimes we end up having to rely on prediction. Although these two strategies have been, the historical verification approaches, there's a number of hybrid models that are currently being explored. And so it's highly likely that some combination of these types of strategies will likely emerge as an approach to verification for our environmental incentive markets in the future. And paying attention to what these hybrid strategies look like is going to be really important to answering the question of whether these types of markets are right for an individual operation. All right, so in terms of future perspectives, right now, that's one of these important things to keep an eye on is the emerging challenges in the sustainability space in terms of how we make good or how we verify our progress toward these types of claims. All right, finishing up very quickly here in terms of some take-home message, we can come up with very different conclusions about the role of animal agriculture in sustainable systems. And that's largely driven by different ways of asking research questions. That doesn't mean that one approach is wrong and the other's right. What it means is that we can learn from both types of research strategies to explore opportunities within our industry. Opportunities for sustainability tend to be highlighted when we explore the intersection between these types of research approaches. And although historically we've really focused on efficiency and sustainability going hand in hand, and they will continue to do so in the future, we often need to think beyond just greenhouse gas emissions, and in particular beyond carbon footprints, to focus on a broader suite of environmental objectives and to focus on the absolute emissions in addition to our footprint emissions. Finally, as we have this emerging space of incentive programs and policies, we need to keep an eye on what the rules are and how those outcomes are verified to help make sure that those programs are right for our individual operations. All right, quick acknowledgement to our various team that have been involved on a number of these different projects. Our lab receives funding from the USDA and from Dairy Management Inc. for some of the projects that I shared with you today. And I'm happy to take a couple of questions. It looks like we have a few in the Q&A.
Yeah, thank you, Robin. I'm really, really excited. I think you did an excellent job. I was a little bit aware of the content you would gonna share with us tonight. So I think it's really nice to hear from someone else that standardization for agricultural practice, it's not the way to go. Sometimes we are hit it very hard because there's lack of knowledge of different uh agricultural productions, and that can be a little bit challenging. So like you said, we have to have a very wide view of practice to better understand where we're going. But I would just invite you to go to the Q&A box, if you don't mind reading the questions and then answering it. We have about, would that be okay?
Yeah, absolutely.
Okay.
So I think there's 5 of them in here right now. I think I can make it through most of those. The first is, we covered a lot of info quickly. Is there any way to view the illustrations in a more leisurely fashion? Absolutely. All of the papers that we presented today are open source, which means that you should be able to access them without having to pay any sort of access fee. Those are available at a variety of different journals, and I'm happy to provide links to the various papers. Perhaps we can send that out via an email list if that's helpful.
Yeah.
They are very dense figures, and so I don't blame you for wanting to spend a little bit more time with them. The next question is, how do you think we can make sustainable systems attractive for producers from a profitability standpoint? And I really think that that's where a lot of these incentive programs have a lot of promise. Being able to receive an incentive for adopting an environmentally focused technology is going to be perhaps one of the only ways that we have in the short term to close that loop. Of course, we already talked about some of the challenges with those, and I think we just need to be really careful about jumping into that space too soon, because there's a lot of questions about how that crediting occurs, what the actual value of carbon reduction is, that we don't have answers to yet. And so there's a lot of risk in that space right now. The other strategy that we have from a profitability standpoint is to focus on this linkage between efficiency and sustainability. But it's important to remember that just like when we're talking about profitability, efficiency or productivity maximization is not the same as optimization. And in many cases, an optimum may not be maximal production. And so we need to think about maybe better support for exploring some of those interim outcomes to find perhaps a happy balance between sustainability objectives while still maintaining profitability. The final opportunity there is better involvement of our food consumers. Increasingly, we're seeing consumers voting with their pocketbooks. There's a lot of interest in purchasing products with environmental labels. And certainly in the US, we're starting to see an expansion of that type of initial effort to work toward capturing that consumer willingness to pay for environmental products. In all likelihood, as this space matures, probably a combination of all of those is going to be the way that we try to make this or help maintain profitability of our industries in the face of a pretty dynamic and shifting market. All right, if we go to the next one here, to your knowledge, are there sustainability studies evaluating the impact of meat from cell cultures? How does this newer technology compare to traditional animal protein production? So yes, there are some studies that have looked at the environmental impacts. In particular, the energy utilization associated with cell culture is quite intensive. But the challenge with this literature that you have to just fully acknowledge is the fact that we don't have an understanding of what a cell culture based meat production system looks like at scale. And so right now, these environmental assessments are largely looking at, a research scale production, and that doesn't pencil economically. And so we certainly wouldn't ever expect it to be how that industry matures long term. There are some projections that have looked at what a maturation curve for that technology may look like, and how the environmental impact might change as that technology matures. But I think the uncertainty around a lot of those assessments is so great that it's probably not necessarily worth focusing on. I had a fascinating conversation with one of the leading scientists in this area at a conference in Washington, D.C. last year, a couple of years ago. And he was advocating that one of the major challenges is that a lot of these assessments assume that cell culture for food production will expand in the same way that things like the pharmaceutical industry has. And there's a lot of limitations to that type of expansion method. And so they actually need a totally different set of equipment produced specifically for meat production from cellular agriculture in order to make it feasible. So until we have a better understanding of exactly what that looks like in the future, I think it's going to be really hard to compare these industries. What I like to advocate to folks is that there's probably a great opportunity for both. There's places where cellular agriculture could have a tremendous impact on food security, where maybe traditional meat products have been unable to have that type of impact. But I don't think that cellular agriculture is going to fully supplant traditional animal-based food production. All right, based on the fact that consumers choose their food based on how it was produced and the environmental impacts of production systems, do you think that food from a more sustainable food chain would have an increase in market prices, just like organic foods? So we did an analysis on this back in 2014. It's a paper in Food Policy, and we were exploring the combinations of environmental attributes that consumers are willing to pay for. And one of the really unique things we found in that analysis was that consumers are willing to pay for environmental impact, but they're only willing to pay about a 5 to 10% premium. If, however, you couple that environmental impact with a local attribute, so instead of paying to support the plastic reduction in the ocean, you're paying to support the water quality in the backyard pond where your kids play, that 5 to 10% increase in willingness to pay skyrockets to about a 70% increase. And so as we're exploring how to maybe better leverage consumers' interest in environmental impacts, making sure we retain that local angle could have a substantial difference in terms of the actual amount that consumers are willing to pay. I will say, however, by all assessments that have been done more recently, this is a very rapidly shifting space. Consumers are increasingly interested in environmental claims in their product purchases. And so that necessity to maintain the local attribute may diminish over time. All right, what are some things an individual rancher can do now to be more sustainable? This is a very unique question that has to be answered on an individual farm. Much like, many of our all of our humans actually have strengths and weaknesses. I think we're all very comfortable with the idea that individual farms have strengths and weaknesses. So what I would do if I was to be thinking about an individual situation is I would look probably at my records or my books. And I'd try to understand where my greatest opportunity costs are right now. Where am I missing out on profitability? And in many cases for our operations, that's going to be a place where they could focus to try and enhance sustainability. Maybe you have a large number of open cows every year. That's going to be an economic challenge. So it's also going to be an environmental challenge, because every day that cow is open, she's producing methane that's not associated with a calf that's eventually going to enter the food production system. So I don't have a one size fits all answer to that question, but that's probably where I would start for individuals. Things like reproductive management, working to ensure you have the best genetics in that herd, being really diligent about grazing management, all of those are going to be things that can enhance sustainability of our production systems. All right, livestock contribute about 41% of greenhouse gas emissions as presented. What is the best way to reduce emissions from the livestock industry? So 41%, this is a really important point, folks. The devil is in the denominator, right? 41% of agricultural greenhouse gas emissions. Agricultural greenhouse gas emissions are not total emissions, and we have to be really diligent as an animal ag industry or as food consumers in general to make sure that we are accurately defining our numbers as we use them to help people understand what they actually mean. All right, so livestock contributed 41% of agricultural greenhouse gas emissions. How do we reduce emissions from the industry? Right now, the industry is focused very much on reducing methane emissions. That's going to require changes in our manure management for our intensively managed livestock. And it's going to require likely inclusion of products to directly mitigate enteric methane emissions. There's a whole host of those products. And there's a number of folks trying to refine our estimates of emissions reductions from those products. So I'm not going to go into too much detail around those, but to say that they're going to be an important part of our solution. But methane is a short-term objective. It's going to be the focus of perhaps the next 10, maybe 15 years. Where we really need to be going beyond methane is to focus on strategies to reduce nitrous oxide emissions and to get our reactive nitrogen footprints under control. And so we're going to see this, this rhetoric or narrative begin to expand here, likely over the next couple of years, to say methane is what we got to focus on right now, but don't forget about the nitrogen components of our production system. So that's going to require things like shifting the way that we manage manure nutrients from our livestock, and in some cases, shifting the way that we handle synthetic fertilizer for crops, for feed production, or for forages. All right, where do producers find these types of incentive programs? That is a great question. They're largely going to be regionally focused. And so I would encourage you to work with your local extension agents. If they're not familiar, I would encourage them to be in pretty steady communication with our specialists at the universities. A lot of these types of incentive programs are coming out of various NRCS grants to our land grant universities. And so it's really about finding the right program that's applicable to your region. Many of them are highly regionally stratified, and exploring whether or not that type of program is right for your operation. All right, I think that makes it through all of them. I think past my time allotment here. So Dr. RancHER, I'm so sorry for that. If there's any further questions, my email's on here. I'm happy to chat with folks.
Yeah, guys, I would just invite you all to reach out if you have any questions. I don't want to hold Dr. Wright here much longer. She does have other commitments. I just want to ask you before, of course, say thank you very much for your presentation. Really enjoy it. And I think there's a lot to digest here still. I think I've learned a lot, and I'm sure other folks have learned a lot too. We have other speakers connecting. We all panelists for the next few days. But what I want you to do before you go, we're going to do the door prize right now before we move to the next section. So we do have 56 people connected right now. So if you could give me a number from 1 to 56, and I'll just find our winner.
It's going to have to be 42.
42. This is actually my lucky number. So So our winner is Mitzi Buckley. If you don't mind sending me your email, I will reach out to you. So let me just send you a text. There we go. I probably cannot type at this time. Okay, that's it. Before we move on to the next portion, thank you very much, Robin. Really appreciate your time with us. Like I said, a lot to digest. I think we learned a lot, and I'm really happy that you had the time to share a little bit with us. So thank you very much.
Absolutely. Thanks, folks. It was my pleasure.
Thank you. Okay, everybody. So before we move on, I have to get my screen. Oops, that's not the one I wanted. I'm having trouble here. Let me stop sharing. And okay, think I can do this. Maybe not. Yeah. Okay, so I hope you guys can hear me well and see me well and see my screen, my slides. So for the second half of the night, you guys are stuck with me. I don't know if that's good or bad. I have to say that when I first envisioned and planned RancHER, I never had in my mind to have myself speaking at the meeting. I really, truly used this platform to highlight other women in academia, in the industry, ranchers, everybody else that's working with livestock. However, last year with our survey, post-program survey, there was a lot of requests to hear a little bit about virtual fencing. And we are actually doing quite a bit of work on those lines. So I thought it would be interesting to bring you guys a little bit of the findings of our research with virtual fencing. So I'm not going to introduce myself. You guys probably know me. Very briefly, I'm Juliana. I'm assistant professor and extension specialist for Oregon State University. I'm also the host of RancHER. This is our third edition, and I'm really happy to have you guys to hear a little bit about our virtual fence studies. So I'll try to make this, I'm kind of lost on my screen here today, but I'll try to make this as applicable as possible. And before I move on to my actual presentation, I do need to organize my screen a little bit here. There we go. I do need to say that everything that I'm going to present it tonight, it is a group effort. We have quite a bit of scientists working with virtual fence here at the URC. We have people on the Oregon State University side. We also have a lot of folks working on the USDA side. And everything that I'm going to show to you guys tonight, it's has some collaborative effort. So if I might not be able to answer questions at the end, I'll make sure to come up with those answers to you guys in case it's something more towards out of my range. But anyway, so for tonight's presentation, I do have a brief introduction of virtual fence. For those that are not very familiar with this technology, I want to give everybody on the same page before we actually started talking about research. So as soon as we get to the research portion, I want to share a little bit of the findings of the past 4 studies we conducted with virtual fencing. There are 3 of them are actually published. We are working on publishing the last one that is focused on blood markers and welfare of cattle when using virtual fencing. That should come soon, next year, I would assume. And then I want to tell you guys a little bit about what we are doing, what we have in terms of ongoing studies, okay? So virtual fencing, right? So fence in general, it's something I have to honestly say I've never thought much about it. I always took it for granted. It's there, it's in the pasture, it's doing its job, it's keeping animals contained, right? That's the main job of a fence. However, we've been seeing those type of fences for years and years and years with very little enhancement and evolution in terms of what it can do, right? It is great to contain or animal ingress or egress, but it really fails to give managers, land managers, the flexibility to optimize physiological requirements of vegetation and actually the nutrition needs of foraging animals. So basically what I'm telling you guys, once we have a fence established, we can really not move that very much, right? We don't have that flexibility. So if we create a fence in a place that's not favorable to requirements of those animals grazing there, we might be stuck with that. Other than that, not having a lot of flexibility, one problem with traditional fencing is that there's a lot of bureaucracy, procedural, logistical barriers that can make that even more challenging, right? And of course, more recently, another problem that we are having, or maybe a challenge we are having with virtual fencing, is the cost associated with it. It is very challenging and time consuming to repair and to maintain, but also is very expensive to build new fences. So here I have some data for Montana in terms of prices for a mile of fence, and we can see this is an estimation for cross fencing to subdivide a larger pasture in Montana. This is a published paper that consider use the NCRS incentives or not. And as we can see here, we are going over the $8,000 per mile of fence. More recently here in Oregon, we got some bids for rangeland and forest environments to build new fences. And we got bids of approximately $13,000 per mile of fence. So this is, to me, it sounds it could be cost prohibitive to build new fences at this level, at this value, right? Also, it is really difficult to invest in something like that at this point, considering all the wildfires and things that can simply destroy a new investment like that. So my whole point with this introduction is, although traditional fence can help us to achieve our objectives, there's a lot of things lately that have been making it more difficult to maintain, to invest, to build new fences, right? So we do need something that could potentially give us more flexibility in terms of availability to manage to the animal level, to be able to go beyond what we've previously thought. And one thing that I would like to introduce you guys, it's actually the virtual fencing, right? So virtual fence uses behavioral modification based on GPS activated collars to then include or exclude cattle from a specific location without a physical barrier. I do feel like what I'm saying here sounds very difficult, but I have a great drawing that will explain to you guys what exactly that is. Things that we think about virtual fence, in some situations compared to traditional fencing, virtual fencing can be less expensive, less logistical challenging. You're gonna just go to a software and draw some lines. That's very easy, right? It can be less labor intensive. And I think what's most valuable of virtual fencing is actually the ability to manage the animal to the individual level. A fence does not give us that ability. We're not able to manage to the individual level, right? So when we think about virtual fencing, I used to say this is a new concept. It's something that's emerging. However, it is not such a new concept. Virtual fencing actually comes from the 70s with the proximity sensing. So we had virtual fence underground, so wires that were tapped underground to prevent animals from crossing a boundary. So that's the old technology we see for dogs actually. But this was something not very feasible. And now with more technology, we're seeing different devices that are actually based on GPS coordinates. So I do have this picture here from Anderson 2007, one of the first persons to actually start working with virtual fence collars for cattle. And this is the one of the initial prototypes of this type of collars. And clearly, this would not have really work in the environment we have here and the type of cattle we have now, right? But a lot has changed and a lot has evolved to the point that we are no longer using any type of device like that. It's a much leaner and easier to operate and work with device. All that to say that we are improving and we are getting better in terms of technology. But just to give you guys a very brief overview on how virtual fence works, specifically in this one here, I'm picturing the Vance virtual fence colors. That's the company we've been working over the years on our research studies. Most of the companies out there do work in a similar fashion. So what I'm going to explain to you guys here probably apply to other virtual fence colors. So most of them will work with a color. Of course, everything starts with a color and a software. So in the software, we design our fences, and within a communication gateway and the satellite, those communicate in the store. So the colors store those locations that can either include cattle within a designated boundary. So here, this dotted line would be our virtual fence, and it's aiming to keep cows inside of this shaped area here. And on the other example here, on the other side of the screen, we are trying to prevent cattle from getting inside of this riparian area or this, I don't know, crop area here. So in this case, the virtual fence, the dotted line here would be an exclusion area. So we have the ability to either include animal within a designated boundary or exclude animals from a designated boundary based on the coordinates that we input in the software. So, like I explained, virtual fence works with the GPS coordinates. We create a designated boundary in a given area. Here I have another example that's actually from the software for one of the studies we use. This is a larger pasture. We can see on this green background, here's a larger pasture that we have here in our research facility. We aim to include cattle within this larger area here, this lighter green color. And to do that, we created several virtual fence boundaries. So you guys can see here, we have actually 1, 2, 3, 4 virtual fence boundaries to prevent cattle from getting out of this area here. So how that works, once we create those boundaries, those colors actually trigger cues to the cattle. So the colors work with auditory and sensory cues that are applied to the cattle when they trespass a designated boundary. So if they try to move out of this boundary here, they would receive that cue. And that leads to a conditioning association to the cues and allows us to have greater management to the animal level. So just before I move on to the studies that I want to talk to you guys and show the findings we have so far, I would like you guys to think about all the possible uses for virtual fencing. When I first started working with virtual fence, I honestly have to say that I didn't believe it would work. I was like, we're not going to stop a cow with a collar, right? But in fact, it is, as you're going to see later, it is highly effective and it does work. And I think the possibilities for virtual fence is actually endless. Every time I start thinking about it, there's something new that comes to my mind. But some of the uses, the target uses that we've seen lately are most likely for grazing restrictions, especially post-fire, to protect sensitive areas like riparian areas, just to monitor cattle location and movement, to help with pasture subdivision, so maybe a rotational grazing type of management. We also think folks trying to use it to avoid consumption of toxic plants, so another type of exclusion. You can exclude that area in your property where you know you might have problems with toxic plants, and also doing some target grazing, as we're going to see later with the research for the fire breaks. So I'm going to move on to share with you guys a little bit of the research we've been conducting at ERC. We have 4 studies that I want to highlight tonight. Those are as I said, the studies from 1 to 3 have been published. You're gonna have a QR code that you can easily access those if you want to reference those later. But basically, we have 4 different studies. One focus on cattle behavior, one focus in removing cattle from grazing recently burned areas of a larger pasture. One study where we tried to develop a fire break area within a larger pasture. And the most recent study that we were looking into, well, animal welfare and how blood markers would change with the use of virtual fence. Okay. So moving to the studies, our first study that I want to talk to you guys, it is the first, the behavior study. The objective of the study was evaluate the efficacy of virtual fence as well as the behavior of naive cows fitted with virtual fence collars for the first time. We hypothesized that the use of virtual fence collars would not negatively impact cattle behavior, and it would be efficient to maintain cattle within a designated boundary, right? So I'm gonna really get to the very specific details of the study. On this study specifically, we only had 11 cows. They were all colored with the very first generation of advanced collars, as you guys can see in this picture here. We don't use those colors anymore. We're gonna see other pictures, I hope, later. So each cow was naive to the colors. They've never been colored with virtual fence. It was the very first time. And we did a lot of behavior evaluations when they were colored. And at the end of the behavior evaluation data, we moved those cows to a new feedlot facility that had new virtual fence areas that were unknown to those cows, just to see the number of kills over time, if the cow would easily learn to respect those boundaries, right? So how we start this study? So we did the behavior evaluation in a testing arena. So you guys can see here on the picture, our testing arena is this green line here, dotted line, which was really close to our squeeze chute. And within the testing arena, we created a virtual fence. So here with this white and red colors, we created that virtual fence boundary. And right on top of that virtual fence boundary, we put a feed attractant. So it was a huge bale of hay. So our virtual fence boundary was at the back of this testing arena, and the very beginning of it, as the cows come in from gate 1, would give the animal a auditory cue, so just a bip, and then we would follow with the electric stimuli, which is a shock, right? So how did we do the evaluation of behaviors on the first time interacting with the virtual fence, right? So we had 11 cows. We did 5 runs for each cows to evaluate their behaviors. So a cow would come in from gate 1, stay in the testing arena for 10 minutes, and then we would evaluate all the behaviors they performed while in here, and if they interact with the feed attractant, if they cross over the boundary, if they move back, everything that they did there, we would record it. It's also important to notice that on our very first run, as I mentioned earlier, we had 5 runs of 10 minutes each. So in the very first run of each single cow, those cows didn't have the collar on. So they could easily walk around, feed from the feed attractant, walk around with no cues being given. We just wanted the cows in the very first run was to get familiar with the testing arena, and then they would move on back to this portion of the test, the chutes, behind the chute, for them to go over again for another run. So beginning on run 2, those cows were collared, and they were, whenever they were in the testing arena with the collars on from run 2, 3, and 4, they could not be in the feed attractant zone. So not that they could not, but the goal was to not allow them to get there, right? So, and then again on run number 5, we removed those collars to see if there would be an aversion to that location, okay? We also collect a lot of other variables such as chute score, chute exit velocity, and collar fit score from those cows, just to see if anything would change with the use of the virtual fence collar. We also evaluate the latency to approach the feed attractant. So we wanted to know if, because the cows were wearing the collars, would they be like afraid to come to the feed or not? Again, we're trying to assess if there's any type of negative association being created with that location that once was a virtual fence boundary, right? Like I mentioned, we also collect a lot of behaviors while they were in the testing arena, what they were doing, what type of behaviors they were engaging. So were they eating the feed attractant? Were they just browsing other things in the testing arena? Were they just agnostic, running, jumping because we have the virtual fence collars on, right? What they were doing on this very first time with the virtual fence collars being fitted to them. Other than that, we also collect the stimuli data. So we counted the number of audio and shock cues that each cow received during every single run. Okay, so I know I've been probably too fast with how we did everything, but here's what we found. So as I mentioned to you guys, I just want to remind you, like, on our run number 1, collars are off and cows could just walk around in the testing arena. And then on run number 5, collars are off again. And again, cows could move freely in the testing arena. But for run 2, 3, and 4, cows had the collars on. And technically, we were trying to maintain them out of the feed attractant zone area, right? So looking at the scores we gave to those cows while in the chute, we didn't see any differences in number over time for the run. So no difference in chute score or chute exit velocity. So the fact that the cows had the collars on didn't change any of those behaviors. But we did see a different collar fit score. And collar fit score is a measurement that we actually developed here at ERC to try to see if we could create an index of better fit for cows. And as we can see, this score goes up, meaning that cows got a little bit more agitated when they received the collars for the first time, even though collars and where the score was given was not being giving any type of cue to the cow. It's just the fact of having a collar will make the cow a little bit more agitated. But as we can see here, from run number 2 to number 3 and 4, that numbers drop to the same level as run 1 and 5, meaning that although there is some agitation, some discomfort maybe with the novelty of the collar, this was very short-lived and didn't last over the other runs. And then when we look at the latency to approach the feed, remember, we wanted to keep cows out of where the feed attractant was, but we don't want to create a negative aversion. So as we can see, by latency to approach the feed, we calculate in seconds that took for that cow as soon as she got out of the chute to get to the feed attractant. As we can see, there's no changes. All the cows tried to go to the feed attractant once they had the opportunity. However, when we look at the time spent within the virtual fence boundary, we see that the percentage is much smaller for runs 2, 3, and 4, meaning that although cows try and test the boundary, they respect and move to another location. They didn't stay within the virtual fence zone when they have the collars on. And when the collars were removed, they would move back to that location without a problem. So without a negative aversion to that location. And then we look at the behaviors the cows were engaging on. Of course, I have highlighted here eating, where the cows actually eating that feed attractant, right? So in run number 1, when they have the opportunity to go for it, they clearly go for it. They spend most of the time engaging in eating behavior. However, in runs 2, 3, and 4, that percentage of engagement and eating behavior decreases a lot, which tells us that virtual fence collars are being very effective at preventing cattle to get to that feed attractant the way we intended to do, right? And when we remove those collars in run number 5, we see that cows resume that eating behavior and start going back to the feed attractant without an aversion to that location, right? Of course, there was changes in the idling behavior during runs 2, 3, and 4. They engaged more in being like just standing still. They were learning what's happening. They're learning the environment. It was a very small testing arena. So they didn't have opportunities to engage in other behaviors. So they just stayed there and waited till they understand where they could go, right? And also when we look at running trot, head shaking, there is an increase in number 2, which is associated with that fit score, collar fit score, right? So the first time that they receive that collar, they tend to be a little bit disturbed, and they tend to behave a little bit different from what we expect. But as we can see, those values decrease over time, meaning that they are calm and they're not anymore engaged on non-desirable behaviors, right? And then when we look at the number of cues over time, we here have only for runs 2, 3, and 4, of course, because that's when the collars were on. We can clearly see that the cues applied decrease over time. Either the auditory stimuli and the electric stimuli, they decrease over time, they're correlating, decrease over time, which means that cows are understanding that there is something there. There is a barrier that needs to be respected. And they tend to rely primarily on the auditory stimuli over time. And we're going to see that data being repeated with other studies. So they learn to respect the boundaries, and they rely primarily on the auditory cues. And then when we finish the behavior evaluation of those cows, we actually moved them to this larger pasture behind our working facility. As you guys can see here, this is actually a screenshot from the software. So this is exactly what you would see on the software when you're creating your boundaries, when you're creating your fences. You see the cows, you see all the like where you're gonna feed those, water sources, gates, and this is actually our virtual fence. So as we were done with the behavior evaluation of those cows, we moved those animals to this feedlot here. We let them there for 8 days. We had this virtual fence set right in the corner in an L-shaped form here, just to see if cows that had been recently collared, how they would react to this new boundary that they have to test and learn by themselves how to go through, right? So what we saw is that they're very smart, let's say this way, and they learn the boundaries of those fences very quickly. And as we can see, the auditory stimuli and the electric stimuli decrease over time because they have the memory and they understand that those boundaries are there, they're present. So those cues were decreasing over time to the point where the electric stimuli over day 7, the last day of evaluation, was less than 1 a day. So they really rely on the auditory cue, and then they move away from that boundary, right? So very interesting data, I would say. Now moving on to our burned area study. As I mentioned earlier, this has also been published. If you want to check this paper, you can just scan that QR code. It should take you to the publication. This study was focused on trying to evaluate the efficiency of virtual fence technology for reducing cattle use of recently burned sagebrush steep. So basically what we wanted to do was to prevent cattle from grazing recently burned areas with a larger pasture. So in this study here, what we had was 6 pastures. So those were almost done. There were 400-meter longs, and they were like 50 meter wide. And we had 2 different treatments. So control virtual fence, control virtual fence, control virtual fence on those 6 pastures. On each pasture, we had about 30% of those pastures burned in the fall before the study started. As you guys can see here is this red area here on the representation of those pastures. So 30% of those pastures were burned. And the goal was to use the virtual fence collars to prevent cattle from crossing to this portion of the pasture here and grazing this recently burned area, which would have fresh new growth grass, right? So we had the cows there grazing for approximately 14 days. We had 3 cows per pasture. And as I mentioned, We had the control and the virtual fence treatments. All cows had virtual fence collars. However, cows on the control treatment, the virtual fence collar was only monitoring location, so we would know where they were grazing, while cows on the virtual fence treatment had virtual fence collars on. So as soon as they tried to trespass here and go to the recently burned area, they would receive a cue. In this slide here, we can see a little bit better. We still have the 6 pastures here. This is the burned area. And right here, this yellow and red lines here is actually our virtual fence management zone. So in the yellow one, we have the beginning of the auditory zone. And then on the red one, we actually have this electrical stimuli. So cows were grazing here. They could graze freely the unburned area if they were in the virtual fence treatment. If they were to cross to the burned area, they would then get auditory and electric stimuli, right? So what we see in terms of cattle location within the burned area, remember, that's exactly what we're trying to avoid. We didn't want the cows to be grazing that recently burned area. And as we can see, our cows on control, which is our black dot here in this graph, here we have locations within burn, and here we have the days of the trial. As we can see, the cows on the control treatment spent most of the time in the burn area within the first few days of the study. This number decreases over time, and it's simply because they simply consumed all the forage available on that recently burned pasture, right? You know that after a fire, there's a growth of forages that are very nutrient rich and palatable for cattle, so they are very attracted by that recently burned pastures, forages. So clearly they were there most of the time consuming that recent growth and that decrease over time. But if we look at the cows that were in the virtual fence collars were on, they barely spent any time within the burned area. They did spend a little bit of the time, but because they were just testing the boundaries, right? Testing if they could cross or not. Once they learned the boundaries, there was negligible use of that forages over time, right? And that also had an effect in forage utilization. As I was saying, here we have the data for the unburned and burned area of those fences. Again, in black, we have the control cows, and in gray, we have the virtual fence cows. In the unburned area, we had greater forage utilization for the cows that were in the virtual fence area, while in the burned area, greater forage utilization for the control cows because they could graze that area. So clearly, we were effective at excluding cattle from that recently burned area, and we were successful at reducing grazing in that specific area. I really like this picture here because it really shows visually what we were seeing. So here we have a traditional fence for that pasture. And this side here, we had the control pasture, and the other side, the virtual fence pasture. This dotted line here shows us to the front, the area that had been recently burned. And as we can see, there's way more standing forage and biomass on the virtual fence pasture because cows could not go and graze this recently burned area here when compared to control, right? So visually, even visually, we can easily see the efficiency of the virtual fence pasture. Moving to the 30 study that I want to highlight to you guys, this one is a little bit different. In fact, we try to include cattle, right? So far, we've been talking about excluding animals from a specific area. In this one, we're actually trying to include them and keep them inside our specific area. So the goal of this study was actually to create a fire break using cattle, so grazing cattle to create this fire break within a larger pasture. So just to give you guys a little visual here, as I showed this picture earlier. So we do have the pasture boundary here in green. So this was a larger pasture where we tried to create this fire break zone in here, this white area within the virtual fences, right? So we have 4 virtual fences created in this fire break area, and cows were meant to stay inside of it. Why did we have 4 virtual fence working as multiple one-way gates, right? The idea was that creating multiple barriers would make it more would make easier to maintain cattle inside. We target the forage utilization for the inside for the fire break at 45%. So once we reach that level, we would move cows out. We were able to graze that location for approximately 1 month. And I think it's important to tell you guys that in this study, we actually have 42 mature cows, and we actually had dry cows and pairs. So some of the cows had their calves, and that's important. You guys gonna see at the results later, but only the cows were collared. So calves could move freely in and out of this fire break zone that we were trying to create. And we learned something with that. So just to give a little illustration of cattle utilization, this is a heat map we can get from the software. You can easily see where cows stayed most of the time, close to the water locations that we had, right? Remember, we had some water here. So I think it's nice to look at it visually. And then when we look at the results, looking at a forage utilization here, remember we were targeting a 45% forage utilization within the fuel break zone or the fire break zone here, and we were very close to it. So we were very effective at creating the fire break using the cows for grazing that area, right? So there was considerable amount of biomass that was removed from that area. But I think the data that we really want to see is the location, the daily location within that field break. And as we can see over time, we had a little bit of field break, animals getting out of that field break, so not necessarily staying within it. And then when we look at the animal categories, remember I told you guys we had dry cows and we have cows with calves in this study. As we can see here in this graph in the middle where we have the dry cows, they actually stay almost 100% of the time within the fire break zone. So they stay and they graze there. However, when we look at the pairs, when we look at the cows that have calves, and remember, only cows were collared, so only cows were maintained within the fire break area. When we look at those pairs, we see a decrease in efficiency of maintaining those animals inside of the fire break zone. And we believe that this is because we have the calves with those cows, and those calves were not collared. So calves are very exploratory. They would go out, they would seek forage, right? We target for 45% utilization. So clearly by the end of the trial, they were running low on forages. So it's likely that cows were going to check on calves outside of the fire break. So we learned a little bit that there might be a little bit of a exploratory behavior as key for the efficiency of this technology, right? But nonetheless, for the dry cows, for the dry cows, we almost got 100% efficiency of maintaining those animals within the established boundary. And now moving to the blood marker study, as I mentioned to you guys earlier, this is a device that will give animals a auditory cue followed by electric stimuli. So there's always a question from the welfare standpoint, is this gonna negatively impact those animal physiology markers, animal welfare? What is going on, right? So we want to explore that a little bit and understanding if there is a negative effect when we use those virtual fence collars with cattle. And in this picture here, we do have the newest models of collar. They're actually now hanging down in the neck of the cow, not on the top as we've seen before. So very briefly on the study design, in this study, we actually had 40 mature Angus cows. They haven't been collared before, so that was the first experience with the virtual fence collar. And then this study was fairly short. We only focus on the 5 days of the training phase. So whenever we color new animals, we do a training phase in a place where we establish those boundaries before moving them to the final grazing area. So for example, on the fire break study that I was just telling you guys, we train those animals in the feedlot with boundaries that we established there, so they are familiar with the cues before going to the final grazing destination. Let's say this way. So cows in this study, they were collared on day 0, and then we process them. We collect a lot of variables on that day, and then we collect those variables again on day 5. As soon as they were processed, we moved them to this paddock where we have those management zones, so the virtual fence, where we collect a number of cues over time and also try to correlate that with the physiological markers, right? So just to give you guys a little bit more familiar with exactly what we did. So this is from A to D, so A, B, C, and D panels here. We actually have moving boundaries for the virtual fence on this study. So we created the boundaries right in here on the back of this larger paddock. So we start with electric stimuli here only. So actually, let me go back a little bit. So on day 0, we work with those animals. We collect all the variables we wanted, and I will go over that in a minute. As soon as we work with those animals, we move them to this paddock here, where no boundaries were actually established on day 0. So they could walk freely everywhere in this paddock here on the very, very first day of the study. On day 1, we turn on the virtual fence boundaries only with the electric stimuli, and they could walk freely here, but not so freely anymore, because now if they got any closer to the traditional fence in the back, they would get an electric stimuli. That continued for day 2, but we actually increased that boundary a little bit. And then from day 3 to 5, we increase even more the boundary inward to the pasture, and we also add the auditory cue. So we start with the electric cue only, and then we move to have auditory and electric cue in terms of the virtual fence and the management zones over time. As I told you guys, we work cows on day 0, and then we work then again on day 5. We collect the body weight, body condition score. Not necessarily we believe that would change, but just because we had the opportunity, we did. Most important here was the blood markers. The blood we collect to analyze markers associated with inflammation and stress. So we analyze samples for cortisol and acute phase protein, ceruloplasmin, and haptoglobin, right? We also look at shoot score, shoot exit velocity, and again, we look at the collar fit score of those cows like we did in the previous behavior study. So when we look at those variables in terms of body weight, body condition score, we were not expecting to see any differences in such a short period of time, so we didn't see anything. There's also no differences in shoot score. There was a difference on exit velocity from day 0 to day 5. So 0 is when we put the collars in the cows, and day 5 is when we work them again. We did see a reduction on the velocity, but personally, I don't think that has anything to do with the virtual fence collars. Although those cows were naive to the collars, those are mature cows that are used to being handled and in the chute. So maybe it's just a matter of handling them frequently, and that variable actually decreased. In terms of fit score, that score goes to 5. We don't have a comparison here because we didn't remove or put the colors back on day 5. But I want to remind you guys from the scores that we saw for the behavior study, and that was about 3 or something. So they do get a little bit anxious when they are collared for this first time, but that kind of changes over time, and they seem to be fine. So it's just something we're trying to develop here to maybe some sort of assessment tool to evaluate if a cow it's a good fit for a virtual fence collar or not. So it's something we're collecting over time. So there's no really comparison here, but it seems that the data is consistent over time for different group of cows. So they will eventually get a little bit disturbed with this novelty, but this is something that they can be fine with over time. And then when we look at the number of kills, I think it's one of the most important and interesting data here. As I mentioned to you earlier, we only have electric stimuli. We had electric stimuli from day 1 to 5, and then on day 3, we started with the auditory stimuli, which is our black bar here. The electric stimuli is the white and black bars. And as we can see, those stimuli really decrease over time, especially when we add the auditory stimuli. It really helps the cow to understand the boundaries in front of them. So they are respecting the auditory stimuli more than they are. They don't get to the point that they need to respect the electric stimuli, I would say. So over those 5 days of acclimation, we saw a reduction on the electric stimuli of approximately 97% from the peak. So the day they got the greatest level, so here days 2 for the electric stimuli to the last day, there was a reduction of 97% on the number of kills those animals were receiving. And when we think about the auditory stimuli, there's also a reduction of 98% in on the same period. So when we turn on the auditory stimuli to the last day that they were being tested, there's a reduction on the number of kills of 98%. So that's telling us that cattle upon training and recognition of the boundaries, they really rely primarily on the auditory stimuli and not necessarily on the electric stimuli, which leads us to our blood data, which is related to stress and inflammatory response, right? And as we can see for cortisol here, which is our stress hormone, we don't see any differences from the day the cows were collared to the day that we end testing those cows, the day 5, right? The cortisol levels are the same over that period of the time, suggesting that there's no stress and no negative implications for animal welfare. Same thing goes for ceruloplasmin. We don't see any differences from day 0 to day 5. However, we do see a little bit change on haptoglobin. Haptoglobin, it's a very broad inflammatory marker. So this increase or this is slight increase from day 0 to day 5 might be related to some other stressors in this situation, in this environment, and maybe not necessarily to the virtual fence. What I'm saying is, if we were to see all those 3 markers going up from day 0 to day 5, I think we could conclude that there was a potential welfare issue here. But just by seeing a slight increase in haptoglobin doesn't make me concerned at all. I do think it could be related to something else in the environment, some other stressor. Also, to corroborate with our data here, others have reported no effects of virtual fence in cortisol and milk, hair, feces, and blood of cattle. So I think we're very well aligned with the findings in terms of stress and inflammatory response markers based on what's been published in the literature so far. And just to finalize today, I want to highlight a little bit of the studies that are ongoing. So this one is trying to use the virtual fence to reduce riparian area disturbances. So the goal is to reduce grazing in the riparian area. So we are using virtual fence to exclude cattle from sensitive areas. So here we have our pasture, this white boundary around this forest allotment here. I'm sorry, this is a pasture, not forest allotment. But we do have a river going over this pasture. So we divided into two portions here. This study is being led by Dr. Boner. I just want to highlight a little bit of what is going on. So the idea is to use the virtual fence to preventing cattle from crossing from this side to this side of the river, right? So basically what we did, we divide this in 2 portions. So on the top panel, cows could not cross. They have the virtual fence set to that they could not cross. If they did, they would get a cue. And in the bottom portion of the pasture, there was no virtual fence established. We're just monitoring location. And so as I want to show you guys, here is the heat map of some preliminary data. As we can see, cows that had color on the top of the pasture barely cross the river, right? While cows that had colors off in the bottom of the pasture here spend most of their time actually on the other side, crossing the riparian area, right? So that's showing the efficiency of the virtual fence collars on preventing animals to visiting those sensitive areas, right? And another study that we are engaging is the use of virtual fence collars in coordination with remote sensing technology to identify target areas to then strategically reduce fine fields. So we use RAP, the Rangeland Analysis Platform, to identify areas where we have fine fields and greater likelihood of fires, greater probability of fires, which in this map here are those areas in darker red. And what we are doing is to use the virtual fence to include animals within that area and do the grazing, target grazing in those areas to reduce those fine fields, to then likely reduce the likelihood of fires in those locations. So with that, that's all I had to share with you guys tonight. I just want to summarize in saying that it seems that cattle quickly learn to identify those boundaries and respond positively to the VF stimuli. Those stimuli tend to decrease over time. Cattle seems to rely primarily on the auditory cues other than relying on the electric cues. We don't see any major negative effects in behavior, physiological markers. It doesn't seem, with that, we don't believe that's any major welfare concerns when using virtual fences. But of course, those were smaller studies, larger term studies, longer term studies using virtual fence collars are needed to better assess how welfare and physiological markers are being disturbed or not by virtual fence collars. I noticed here that my QR code has kind of cut it here, but we do have a YouTube playlist about virtual fence in the YouTube. So if you type URC virtual fence, that should come up. We had some nice videos talking about our research and also how to establish towers, how to make it mobile, and that's about it. So just to summarize, we tend to say that virtual fence is not an iron gate, but neither is traditional fencing, right? But virtual fence does allow for management to the individual level, and I think that's a very beneficial point. So with that, I will be happy to answer any questions, and I'll stop to sharing my screen here. You guys gonna see me here tonight, tomorrow night, and the next night. So if I don't answer questions right now, we can chat more about later. Also, we have my email and my phone number here. So if you have questions, I'll be more than happy to answer those later. But for now, I'm gonna stop sharing my screen, and I'm gonna go to the questions. Let's see here. Okay, there's 2 questions here. So just out of curiosity, what happens if a cow walks through the boundary but do not respond to the auditory electric cue? Would the collars be deactivated after a while? If so, how long after? That's a great question, and I can only speak about a few of the brand we are working with. Those are some settings that can be changed. There is security settings where if a cow start running towards the boundary, into the boundary, the cues will be deactivated because of the velocity of the cow that the cow is traveling. So I would say that each individual company has different settings, but those cues can be deactivated based on non-compliance. Let's put that way, right? That's also why we do put multiple boundaries, because if they escape one, there's another one, and perhaps they will move back in. Another important point is that virtual fences are unidirectional, unless fence is. So cows only get cues or stimuli if they're moving towards the fence and not trying to come back where they should be in. I hope that answered your question. So Dr. RancHER, to your knowledge, are there studies that try to maintain two separate groups in a big area without animals moving from one group to another? I work in Brazil where I have big soybean producers using grass as crop rotation. Such technology would help, as these areas usually lag and do not support a lot of fencing, subdivide animals. Yes. So the question is asking about trying to separate two groups. Actually, we have not done any research on those lines, but by experience, we can say that actually on the riparian study, what happened, we actually got a mix-up of cattle. So we did have the virtual fence right in the middle of the pasture. And because we turned it on, we were able to sort animals. So probably is possible. So it is possible to sort animals within the virtual fence collars in a larger setting. I think a lot of the virtual fence, it is being creative. We need to think about how we can make it work, but a lot of just being creative on how you can use it. But definitely we can separate animals in a larger area, as we've seen with the riparian study. When animals by mistake got mixed, then we turn it on and each one got to its side. So I think that answered the question. Thank you. Next question. Thank you for the broad range of studies you're doing. Thank you. Does virtual fences need a cell reception? So that's a good question. As I said, virtual fences, they change. There's quite a few in the market right now. We do work with fence. Fence does need a little bit of cell coverage. If we decide to work with them, they will likely ask you for a KMZ file of the cell service over your location. They can see if they're gonna be enough reception to make the collars online. That's what I want to say. Another option is you can pre-record those locations and set those animals to a location without cell service. So if you want to do changes as you go, you do need the service, self-service, cell coverage. But if you don't need to do those changes as you go, you can likely use in an area that doesn't really have coverage. Okay, next question. Oh my goodness. Are there different brands of virtual fence products and there's some kind of metrics to evaluate the costing for varying areas? That's a really good question. So to my knowledge right now in the US, we have Vance, Gallagher, Corral, Halter, and maybe another one. So I think there's 4 or 5 brands. Commercially available, to my knowledge, we only have Vance. I know about 1 or 2 producers that are using Gallagher, but I think they're on the testing phasing. They're not necessarily available yet. And I know prices will vary. There's people working with more of a subscription type of thing. A lot of the new technology is going like that. So you pay yearly, you pay by animal, you pay monthly. So honestly, I cannot speak much for other companies because we are only working with Vance so far. And that's the only one that I know is commercially available. But I would say in the future, we will gonna have something that will allow us to try to estimate what is the cost benefit for each producer in each location, which technology most favors your production settings, hopefully. Okay, if a cow gets out, can she get back in without getting any stimuli? Yes, that's a great question. So virtual fence with Vance, it's unidirectional. They only get stimuli if they're getting out of that established boundary. If they're trying to go back in, they will not get any stimuli. Okay, very interesting studies. Are there plans for more studies focused on pair red-handed cows or focusing on bulls? I do have particular interest in continuing the studies with pairs. I'm not very aware of any studies with bulls because of an anatomical challenge. Those are larger animals, and it's likely that the capacity of those colors will not be enough to stop a bull. So I'm not gonna talk much more on that. But on the pair side, I do want to do, I'm interested in doing more studies to understand if there's like, what is the spatial distribution of those animals in the pastures? Maybe can we keep a few of the cows with collars and a few of the calves, not necessarily the entire herd? Also, I would like to doing some evaluation of cattle personality, and this is in the discussion with some collaborators to see if cows and calves that have a more exploratory behavior or personality would break more those boundaries over time. So this is something we've been thinking about. We might do some studies on those lines. Okay, one more question. So I have a question regarding cows with the calf. Does only the mother receive the collar? So on that specific study, yes, only the cows had the collars, not the calves. One thing with growing animals is that we recommend that you check those animals quite often because those necks are growing too. If you set a collar and don't go check on them, there is a likelihood that the animal will grow over the collar, right? So it's always important to check on those animals that are growing. Okay. Hi, Julia. Thank you. I just saw your message here. Glad you joined us today. Okay, I think I have answered all the questions we had here, I hope. If I didn't, you guys know where to find me. I will say that I'm really glad with the turnout tonight. I hope you guys will join us tomorrow. I do have our panelists, our speakers for tomorrow. Thank you, girls, for joining. Because of the time, I'm not gonna open the floor to them to talk about their talks, but we are here tomorrow. We're gonna be here tomorrow night. I hope you guys can join us. I think we have a lot of amazing talks tomorrow, focus on animal welfare and the use of antibiotics. So I think it's going to be another great night of very interesting subjects. So you guys are more welcome. I hope to see you guys here. I hope to see you guys are more than welcome to join us tomorrow night. So thank you very much, guys, and have a good night. See you tomorrow.